In this video, we are going to learn how to use the double angle formulas to find exact values. Now, at the top, I have written down all the double angle formulas for easy reference. And for our examples, we're going to use the information given about the angle theta on the interval of 0 to 2 pi to find the exact value of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. So we'll see here we have sine of theta is equal to 3/5, and the theta is on the interval from pi over 2 to pi. This interval indicates that we are in the second quadrant. So it's good to know. Because now if I want to draw a reference triangle, I'm going to draw it into the top left quadrant. And when you're in the top left quadrant, that means you have a negative x value and a positive y value. So now, for sine of theta is equal to 3/5, I want to find sine of 2 theta. So sine of 2 theta for part A, sine of 2 theta is equal to 2 sine of theta times cosine of theta. Now, luckily, I know what sine theta is. That's 3/5. But I don't know what cosine of theta is yet. So that's what I'm going to use this reference triangle for here. So for this reference angle here for theta, I know that sine is opposite over hypotenuse, so 3/5, and I need to find the adjacent side. So I will use the Pythagorean theorem, a squared plus b squared equals c squared, and I'll get that 3 squared plus b squared equals 5 squared, 9 plus b squared equals 25, b squared equals 16, and then b equals 4. So this side over here will be 4. And then I know it's negative because I'm in the fourth quadrant, so my x-coordinate should be negative. And now cosine of theta is -4/5, adjacent over hypotenuse. So now, if I want to, I can now plug in that -4/5 in for cosine and simplify and get 2 times 3 times -4, which is -24 over 5 times 5, 25. Now let's look at part B, and let's try to find cosine of 2 theta. Now I have 3 different choices of formulas to use. Even though I do know what cosine of theta is, I'm going to go with the middle formula since I'm given sine theta as a value. So I'll plug in 3/5 for sine, so I get 1 minus 2 times 3/5 squared, give me 1 minus 2 times 9/25. So I'll get 1 minus 18/25, and that's now 25/25 minus 18/25, which gives me 7/25 for cosine of 2 theta. Now if I'm looking for tangent of 2 theta, that formula requires us to know tangent, because it's 2 tangent of theta over 1 minus tangent squared of theta. So tangent, using that same reference triangle, is opposite over adjacent. So tangent of theta is equal to 3 over -4, so -3/4. And I can go ahead and plug in -3/4 in for tangent. So I'll get 2 times -3/4 over 1 minus -3/4 squared, giving me -6/4 over 1 minus 9/16. So what I can do here, I need to simplify this expression. Negative 6/4 is negative 3/2. In my denominator, 1 minus 9/16 is 7/16. And now I'll have negative 3/2 divided by 7/16, which is the same thing as multiplying by 16/7. And then I can do 16 divided by 2. There's a 1 down here, but an 8 up here, giving me negative 24/7. And a good way to check this is I know that tangent is sine over cosine. So I can actually put negative 24/25 over 7/25. And that should give me negative 24/7. So a nice way you can double check. Now let's try to do this example. Here I'm given that tangent of theta is equal to negative 3 and sine of theta is less than 0. So this doesn't indicate necessarily what quadrant I'm in yet, but it does narrow it down to two different quadrants. It's either quadrant 3 or quadrant 4, because sine is negative in those two quadrants. Now tangent is also negative, but I know that tangent is positive in quadrant 3 and negative in quadrant 4. So I'm going to go with quadrant 4 for where this triangle is going to be, reference triangle is going to be made. So I'll draw a triangle, put an angle out to the bottom right into quadrant 4. This just indicates that my x value is positive, my y value is negative. And tangent here is negative 3. But I may use the statement tangent of theta is equal to negative 3 over 1 to figure out where everything goes. Now tangent is opposite over adjacent. So the 3 will go opposite, adjacent will be 1. And now I'll go ahead and try to find the other trig values. So starting with part A, sine of 2 theta. I need to know sine of theta and cosine of theta. And I don't know either of them yet, I only know tangents. So I need to find them, but I need the hypotenuse to find them. So I'm going to use the Pythagorean theorem, which will be give me 1 squared plus negative 3 squared is equal to c squared. So 1 plus 9 is equal to c squared. 10 is equal to c squared. So the hypotenuse is the square root of 10. So sine of theta, which I'll put up here, is equal to negative 3 over the square root of 10. And cosine of theta is equal to adjacent over hypotenuse 1 over the square root of 10. Now I'm not going to rationalize those denominators, because when I multiply this out, it might just fix it on its own. So sine of theta is negative 3 over the square root of 10. Cosine of theta is 1 over the square root of 10. And now when I multiply all of these across, I'll get 2 times negative 3 times 1, which is negative 6, over square root of 10 times square root of 10, which is just 10. And then this can simplify just to negative 3/5. So it was really nice that I had 2 square roots of 10 to multiply to each other, so the square root just went away. Now part B, we have to do cosine of 2 theta. Now in this case, I wasn't given sine or cosine, so I can use any of the formulas, and I'll just use the first one because we haven't used it yet, which is cosine squared of theta minus sine squared of theta. Cosine squared would be 1 over the square root of 10 squared minus sine squared, which was negative 3 over the square root of 10 squared. Give me 1 squared, which is 1, over the square root of 10 squared, which is just 10, minus negative 3 squared, which is a positive 9, over the square root of 10 squared, which is 10, and 1 minus 9/10 is negative 8/10, which simplifies to negative 4/5. Now for the last part, for tangent of 2 theta, we know that formula as 2 tangent of theta all over 1 minus tangent squared of theta. Now luckily I'm given tangent of theta, so I can write this as 2 times negative 3 over 1 minus negative 3 squared, which simplifies to negative 6 over 1 minus positive 9, giving me negative 6 over negative 8, which simplifies to 3 over 4. And again, I can double check this because I just found the other ones, but if I put negative 3/5 over negative 4/5, that should give me positive 3/4. And that is how you use double angle formulas to find exact values.